basically, we've been looking at ocean changes around New Zealand in the Southern Hemisphere, and there's a list of my co-authors. This work's been going on for about 10 years, and this is another piece that we're just trying to finish off now. Thanks, Paul. Next. So basically, we've been using the models and observations to look at the Southwest Pacific Ocean for the best advice on New Zealand waters. We've been looking at the whole range of what's possible: physical, biogeochemical changes, fisheries changes, what causes, especially as I'll show you, significant circulation changes and why, and then some conclusions. Next, please, Paul. So the setting, so this you can see New Zealand's in the center there. So this is the Southwest Pacific Ocean. And what we have is a boundary between two sets of water masses. So we have warmer subtropical water to the north, and then cooler subantarctic water to the south. What I'll point out is the bathymetry of New Zealand sits across the boundary of these two water masses. And I will be talking about the specific area Bounty Trough, which is an area of deeper water close to the New Zealand area, but actually surrounded by some higher bathymetry. And that has specific circulation features, which I'll show now. Thanks, Paul. And so again, here's the general circulation pattern that you find around New Zealand. And you can see the warm water boundary, which is the red-brown marking steering across from Australia around top of New Zealand and then across Chatham Rise. And then to the south, you've got the Antarctic circumpolar current sweeping around the south. And then in between, you see in Bounty Trough, which is pointed out by the red arrow, you see this tight little bit of circulation that goes in and around Bounty Trough in a clockwise direction. And yes, it seems a small part of the general global system, but I'll show you what significance it has. Next, please, Paul. And so, not surprisingly, we looked at end-of-century changes in these models, and much the same as the rest of the world. Temperatures going up and increase quite significantly with this mixed layer depth reduces. And these changes combine to see changes in phytoplankton and zooplankton, as you might imagine. And then we looked at the consequences of these in some fish MIP models, which I'll show in a second. And basically, we see that there's strong declines in all biomass around New Zealand. Of course, the confidence as the confidence in these features goes down. So basically, we have the highest confidence in the physical variables, then the least in the biogeochemical, and then the fish MIP ones least. But still, they give you indications of what kind of systems you might be seeing. Thanks, Paul. And so here are the kind of simple examples that you see. You see on the left-hand side is the SST, and you can see that by end of century, we're seeing 2 to 3 degrees in the highest emissions profile around New Zealand. And this is everywhere. On the right-hand side is an example of the iron. So you actually see that iron actually increases, but this is associated with the changing in the mixed layer depths in the biogeochemistry. And there are some specific patterns that I'll come back to later in the talk. Thanks, Paul. So here are some interesting examples of biogeochemical variables. And what you can see, the blue is where it's reduced relative to present day, and the red is where it's increased. And what you see for most of these three of these parameters is that in the subtropical waters, where it's getting warmer and warmer more, the reductions they all have reductions, whereas in the cooler subantarctic water, there are small increases. But on the bottom right-hand corner, you can see that's the oxygen content. That's down to about 600 meters. And you can see that by end of century around our region, the oxygen is all reduced. So that's quite a significant change relative to present day. Thanks, Paul. So these are three examples of fish MIP models that we examined, and what we show here is what's called the total consumer biomass, which is just a measure of how much matter is in the system in the higher parts of the trophic system. And what you can see in each of these is that they're all blue. And the blue means that they're all reduced. So regardless of the model and regardless of how they actually do their parameterizations, they're all showing that by the end of century, there's quite significant reductions in all the systems. Thanks, Paul. So when we were doing this work, we'd updated this one from work in 2018. We found some quite specific features in Bounty Trough. And I've showed 3 examples here. And what you can see is there's quite this specific tongue that seems to exist. And you can see in the SST, you have this tongue that sits on one side, and this is reflected in the changes in the surface nitrate. And you can see that this tongue also has a manifestation in terms of integrated primary production. And so we were quite mystified when we saw this. You know, I thought it was the specific models we were looking at. So the real question is, why is this happening at all? So next one, please, Paul. So what I went back to and looked at was the changes in the surface circulation that the CMIP models were representing around this region. And what I show here is percentage changes. So where the percentage change is positive, that means the current is increased. And where the percentage change is blue is negative, that current in that direction has reduced. And what you can see on the left-hand one is the east-west flow, and you can see that most of that is increased across the Southern Ocean. And then what you can also see is in Bounty Trough, there's quite a few areas of blue, so quite a lot of the circulation has actually been slowed down. And on the right-hand side is the north-south flow. And in a similar way, it's not quite as clear because the scale is quite smaller, but you can see that there's a connection that goes in that's reduced, and it's reduced both going into Bounty Trough up on the side of New Zealand. And so what we're finding is that there's a curious circulation change. And of course, we had another look at this, and I'll come on to that in a minute in terms of whether CMIP models are actually capable of representing what we see. Next one, please, Paul. And so just to summarize that, so on top of the overall significant model signals we see, which is the temperature changes and the biogeochemical changes, we see the circulation change around Bounty Trough. This is all fine in the models, but is there any observational evidence for such changes actually happening now in the present day system? So now we'll go on to look at the observational evidence. Thanks, Paul. And so here are the observations. On the left is observations of sea surface temperature, and on the right is sea level anomaly, which is the height. And what you can see is that in the blue square on the left-hand side, you can see this quite strong signal emerging, which is quite a significant increase in SST. And on the right-hand side, this is associated with a sea level anomaly increase. And this has been written up in GRL, and what they found is that the rate of increase of the SST and the sea level anomaly were about 5 times the global average. So although it's quite a small region, there's something peculiar being seen in the observations. Thanks, Paul. Next one. And now these are circulation changes. These are anomalies. So hopefully the arrow's sharp. Vectors are always difficult, but basically what you can see is in the area where the red boxes, the blue boxes on the left-hand side, the circulation is, the arrows are actually pointing opposite to the direction of where the flow was going. So this is consistent with what the model was showing. It may not be exactly the same, we wouldn't expect that, but actually the observations are showing that indeed there is a slowdown in the circulation around this part of the world. Thanks, Paul. The next one. And so this emphasizes the northward flow that we were seeing before. Again, all the arrows, I think most of the arrows that you can see, hopefully you can see, are actually going from north to south. So these are anomalies. So they're in opposition to the general direction of the flow that was normally there on average. And so what we see is that although the mean flow around the bottom is increasing, the flow into New Zealand is actually reducing. Again, these are observations. Thanks, Paul. This is a wider picture. So this is the wider Southern Ocean. And these are from reanalysis fields for flows and also from models. This work is taken from Shi et al. In 2021. And what they found is that if they integrated the models and they integrated observations, that what they see is that the surface ocean around these latitudes is indeed accelerating. And it's been accelerating from about 2000 or so, and it's just continued to accelerate. And so this is consistent with what we're seeing. Next one, please, Paul. Thanks. So what do we think is going on? So here's a schematic indeed of what we think. So the big red arrows around the bottom is the accelerated flow in the Southern Ocean. So that's been observed. And then what we think is going on is that because this flow is accelerated, we seem to be seeing less attached flow that's entering into Bounty Trough. So what we're seeing is that the small blue arrows, they've reduced, and then the red arrow around the top, bringing in the surface water, has increased. So we think that the changes that are occurring in the wider Southern Ocean are actually driving local circulation changes within Bounty Trough that seems consistent. Next one, please, Paul. So just to re-emphasize this, so these are from the models, and these are examples of changes in zonal flow within Bounty Trough, and so these are at the scales at that scale. And what you can see is each of the examples is an example of from the model zonal flow integrated over those regions. And what you see in each of them is that the flow that was in one direction has changed. So the top flow, the flow is reduced. The middle flow was a negative flow, so it's become less negative. And the bottom flow is the flow that's in the Southern Ocean that has steadily increased. And so the model is capturing those three phases, even though they're at some of the scales of Bounty Trough. Next one, please, Paul. These are the examples of the flow, the northward flow that was northward flow. And again, the pattern is very similar. You see that what you see is that the flow is reducing in each of them. And so what we're seeing here is even in the Southern Ocean, we're seeing that the connection between the flow in the Southern Ocean is weakened as it connects the cooler sub-Antarctic flow into the area. So what we think we're seeing here is that the two things, there's the wider region flow changes that I'll describe in a second, but also the ability of the CMIP models to capture scales that we didn't think they would be able to. And so this is a combination of CMIP 5 and CMIP 6 models. So the improvements in the models and the resolution has actually started to capture some of these features, which was a surprise to us, but it's consistent with the pattern that we're seeing. Thanks, Paul. And so what do we think is actually going on? Well, we haven't done this, but lots of people have been looking at it. So there's the large scale drivers of this regional change. And if you look on the left-hand side, you'll see that this is the vectors of the winds and also the wind stress curl. And generally what's happened is, of course, as we know in the Southern Ocean, the winds have increased, but not only have they increased, they've also moved slightly further south. And that's associated with changes in where the wind stress curl is also occurring. So on the right-hand side, you see the consequences of these wind changes. On the top right-hand side, you see the sea level rise. And you can see that there are the patterns that are associated with the gyral systems, but basically you see that the water around New Zealand is rising, and the water in the Southern Ocean has reduced, which is part of that gradient that we're seeing. And then the bottom one shows the ocean heat content. So there's a double whammy here. So what's going on is not only is there a circulation change, but the way that the heat is being redistributed means that the wind is contributing to an increase in ocean heat storage, particularly at the latitudes. Well, I'm focused on the southern hemisphere of New Zealand, and so this general piece of work is showing that what we're seeing is part of a larger trend system in the whole Southern Ocean and Pacific. Thanks, Paul. Next one. So this just reiterates what I said before about the changes. Many of the changes are consistent changes that other people see in all the models around the New Zealand region. But like I say, the thing that was a surprise to us and the thing that popped up is this very specific circulation change at the scales of Bounty Trough. But interestingly, which led to the paper that we first published, was that the Bounty Trough changes are actually consistent with the observations, which was again a surprise to us. And if we believe that the models are actually doing something right on the climatological scales, what they show is that these changes are not transient. that they actually persist to the end of the century as far as the models are concerned. So the embedded changes that are already in the system now continue to persist. They're not that they don't just turn over and come back again.
We've got 5 minutes, Graham.
Oh, I told you I get there. We're almost there. Yeah, I can't slow down now, Paul. Next one, please. Thanks. And like as I say, these regional changes can be linked to Pacific-wide atmospheric and ocean changes. In particular, all the southward shifts associated with the winds, and the consequent gradients that seem to be driving the circulation patterns that we see. And this picture has emerged from analysis of CMIP models using present day and future states and observations. So like we say, we've been building this picture over 10 years and this was relevant that it turned up. Thanks. I think there's just one more. Yes, okay. As with Letty, CMIP 7 is clearly on the horizon. So in terms of future work, we note that with CMIP 7 approaching, there's going to be some more work for us to do because my understanding is that they've revised the scenarios. So there's not going to be a clear one-to-one between CMIP 5 and CMIP 6 had a kind of continuity of scenarios, whereas under CMIP 7, they've now come up with these plausible scenarios, which I'm still trying to understand, but I can see what they're getting at. So in terms of work that we would have to do, would be an interesting look at the new models, especially as they now extend to 2025. So it's not that they become reanalysis or anything, but they cover quite a bit of the change period that's actually occurring in New Zealand now. And so that would be quite a good test for us to understand how well the new CMIP 7 models continue to represent the flow around Bounty Trough as we saw between CMIP 5 and CMIP 6. And in that regard, we hope that CMIP 7 will help the predicted pathways for the ocean states around New Zealand. So hopefully, if anyone has the energy to pick this up, we can provide much better advice in terms of future states for the New Zealand Ocean. And I think that's it. Is there one more, Paul? Thank you. I think the next one was just thank you, was it? Yes. Okay, thanks.
Thank you, Graham. I'll just stop sharing. Has anybody got any questions? Otherwise, if you have got some questions, I'd suggest put them in the chat so that we can at least fit Ruben's talking. But I think we've got a couple of minutes. I'd just ask one question, very quick question. Obviously, okay. In the initial introduction, you said this has an impact on fisheries around New Zealand because the reduction in the even though there was increased iron, there was a reduction in overall like phytoplankton and.
That's right.
So is this information being fed to, say, the government in terms of, or to the fisheries industry and other interested parties in terms of you need to plan for this and what to do about it?
It is. These are communicated through meetings and the publications, so they know about these predictions. Of course, as I described, the confidence in the models decreases, but I think that while a fisheries person would never say that the FishMIP models are the best things that we should use to base future strategies on, it's pretty clear that the signals that we're seeing are consistent. And so, yes, we hope that they're listening.
Okay.
We present it to them, that but what more can we do? I don't know.
All right. Thank you, Graham.